The universe wants us dead. I don't mean that metaphorically. I don't mean it's indifferent to us. I mean the universe is actively, persistently, relentlessly trying to kill us. And the proof is everywhere. In the vacuum of space, in the radiation that floods the cosmos, in the asteroids that still slam into planets, in the gamma-ray bursts that sterilize entire regions of galaxies, in the structure of physics itself. We survive not because the universe is hospitable. We survive despite the universe doing everything possible to prevent life from existing. And when you actually look at the evidence, when you see how many ways the cosmos is designed to eliminate biological complexity, it becomes clear why we might be alone. Not because life is rare, but because the universe kills it. Systematically, efficiently, without mercy. I'm going to show you the proof. I'm going to show you every mechanism the universe uses to destroy life. And I'm going to explain why the fact that we're here at all is not a blessing. It's a statistical anomaly, a temporary exception to a universal rule. The rule is simple. The universe does not want complex structures. It does not want order. It does not want consciousness. And it will use every law of physics to grind existence back down to equilibrium, to heat death, to nothing. Let me show you how. Start with the most obvious evidence. Space itself, the vacuum. 99.9999% of the universe is empty space. And that emptiness is lethal. No air, no pressure, no warmth. If you step into the vacuum without protection, you die in less than 2 minutes. Your blood doesn't boil like the movies show. That's a myth. But the oxygen in your lungs expands and ruptures your alveoli. Your tissues swell as dissolved gases come out of solution. You lose consciousness in about 15 seconds from lack of oxygen. Brain damage begins in 1 minute. Death follows shortly after. The vacuum doesn't kill you dramatically. It kills you efficiently, quietly, thoroughly. And space is almost entirely vacuum. There are a few atoms per cubic meter in interstellar space, essentially nothing. The universe is predominantly a void that cannot support life. Life requires matter, energy, structure. The universe is structureless emptiness, and that emptiness surrounds every planet, every star, every galaxy. We exist on a thin shell of rock and air wrapped around a ball of molten iron, floating in an ocean of nothing that would kill us instantly. The universe made room for death, not life. But the vacuum is just the beginning. Space is also filled with radiation, cosmic rays, high-energy particles accelerated by supernovae, black holes, active galactic nuclei, protons and atomic nuclei moving at 99.99% the speed of light. When these particles hit biological tissue, they destroy it. They shred DNA, they create free radicals, they cause mutations and cancer. On Earth, we're protected by the atmosphere and magnetic field. In space, you're naked against the radiation. A Mars mission would expose astronauts to radiation doses equivalent to decades of smoking. A trip to another star system, the radiation would kill you long before you arrived. The universe fills the void with particles that destroy complex molecules. It's not passive hostility, it's active sterilization. The cosmos is bathed in radiation from every direction. The cosmic microwave background, the afterglow of the Big Bang, is the least dangerous radiation out there. And even that represents the heat death of the universe, the eventual equilibrium where all energy is uniformly distributed and nothing interesting can happen ever again. The universe is moving toward that state, toward maximum entropy, toward heat death. And radiation is how it gets there, by breaking down structure, by destroying order, by killing life. Then there are asteroids. The solar system is filled with them, millions of rocks orbiting the sun. Most are small, harmless, but some are kilometers across, and occasionally their orbits intersect with Earth's. 65 million years ago, an asteroid 10 kilometers wide hit the Yucatan Peninsula. The impact released energy equivalent to billions of nuclear weapons. The explosion vaporized the asteroid and a huge chunk of the Earth's crust. A fireball spread across the sky. Tsunamis hundreds of meters high swept across coastlines. The atmosphere filled with dust and soot, blocking out the sun for years. Temperatures plummeted. Photosynthesis stopped. The food chain collapsed. 75% of species went extinct, including the dinosaurs. They had ruled the Earth for 165 million years, and an asteroid ended them in an instant. This wasn't a freak accident. This is what the universe does. It hurls rocks at planets, constantly. Earth has been hit countless times, The craters are everywhere. Some are obvious. Most have been eroded away by time. But the evidence is clear. The universe bombards life-bearing planets with extinction-level impacts. And it's not just Earth. Every rocky planet and moon in the solar system is cratered. The Moon, Mars, Mercury, they're covered in impact scars. The early solar system was even worse. During the late heavy bombardment, about 4 billion years ago, the inner solar system was pummeled with asteroids. Earth was hit so often that the surface was molten. Any life that might have started would have been sterilized over and over again. The universe doesn't just make it hard for life to start. It actively destroys any life that does start, with rocks thrown from space at tens of kilometers per second. And this isn't unique to our solar system. Every planetary system has asteroids. Every planet that could harbor life is under constant bombardment. The universe is trying to kill you with rocks from space, and eventually it will succeed, maybe in 1,000,000 years, maybe in 100 million. But an extinction-level asteroid will hit Earth again. It's not a question of if, it's a question of when. And when it does, the universe won't care, because the universe doesn't want you here. But asteroids are slow, predictable. The universe has faster methods, gamma-ray bursts. These are the most energetic events in the universe, more energetic than supernovae. A massive star collapses into a black hole. In the process, it shoots jets of matter and energy out along its rotation axis at nearly the speed of light. These jets slam into the surrounding gas, creating a burst of gamma rays. For a few seconds, a gamma-ray burst can outshine the entire rest of the universe combined. And if one of those jets is pointed at Earth, we die. The gamma rays would strip away the ozone layer in seconds. Without ozone, ultraviolet radiation from the sun would sterilize the surface. Plants would die, photosynthesis would stop, the food chain would collapse. Any life that survived the initial radiation burst would starve, and we wouldn't see it coming. Gamma rays travel at the speed of light. There's no warning. One moment you're fine, the next moment the sky lights up and you're dead. How often do gamma-ray bursts happen? We detect about 1 per day in the observable universe. Most are billions of light years away, too far to hurt us. But some are closer, and the danger zone is large. A gamma-ray burst within a few thousand light years could cause a mass extinction on Earth. Has it happened before? Possibly. The Ordovician extinction, 440 million years ago, killed 85% of marine species. Some scientists think a nearby gamma-ray burst might have been responsible. We can't know for sure. But the timing matches, and the mechanism works. The universe has weapons that can sterilize planets from across the galaxy, and it uses them regularly. We just happen to be in a quiet neighborhood, for now. But galaxies are dynamic. Stars move. Orbits change. Eventually our quiet neighborhood won't be quiet anymore. And when a massive star within a few thousand light years goes supernova and points its death beam at us, there will be nothing we can do. The universe will have succeeded. Again. There's also the sun. Our sun. The star that makes life possible. It's also trying to kill us. Solar flares. Coronal mass ejections. The sun regularly hurls plasma and radiation into space. Most of it misses Earth. Sometimes it doesn't. In 1859, the Carrington event, the largest solar storm in recorded history, hit Earth. Telegraph systems around the world failed. Some caught fire. If that happened today, with our dependence on electronics, the damage would be catastrophic. Satellites would be fried. Power grids would fail. GPS would stop working. Communications would go dark. And that was a relatively mild event compared to what the sun is capable of. The sun could produce a flare 10 times stronger, 100 times stronger, and if it hit Earth directly, it would destroy our technological civilization in hours. We'd be thrown back to the pre-electric age. Billions would die in the chaos that followed, and the sun doesn't care. The sun is a ball of plasma undergoing nuclear fusion. It has no awareness, no intent, but the physics of its operation includes the capacity to sterilize its own planets. The universe gave us a star that could kill us, and someday it will. Even worse, the sun is getting brighter, slowly, over billions of years. As it burns through its hydrogen fuel, the core contracts and heats up. The outer layers expand. The sun's luminosity increases. About 1 billion years from now, the sun will be about 10% brighter than it is today. That doesn't sound like much, but it's enough. 10% more solar energy means Earth's average temperature rises by several degrees. The oceans start to evaporate faster. Water vapor is a greenhouse gas. More water vapor means more warming. More warming means more evaporation. It's a runaway feedback loop. Within a few 100 million years, the oceans boil away completely. Earth becomes Venus, a scorched hellscape with surface temperatures hot enough to melt lead. The atmosphere becomes unbreathable. Life ends. The universe gave us a sun with a built-in timer. In about 1 billion years, it detonates, and everything on Earth dies. Not because of anything we did, but because stellar evolution is programmed to sterilize planets. The universe wants us dead, and it will get what it wants, eventually. Let me tell you about something even more terrifying. Vacuum decay. This is speculative, but the physics is sound. The Higgs field, the field that gives particles mass, might not be in its lowest energy state. It might be in a false vacuum, a metastable state, like a ball balanced on a hill, stable for now. But if something nudges it, it rolls down to the true vacuum, the lower energy state, and when that happens, a bubble of true vacuum forms. Inside the bubble, the laws of physics are different. The Higgs field has a different value. Particles have different masses. Atoms can't form, or they form differently. Chemistry doesn't work. Biology is impossible. And the bubble expands at the speed of light, consuming everything, converting it to the new vacuum. You wouldn't see it coming. One instant you exist. The next instant, the bubble wall passes through you, and you cease to exist. Not just you. Everything. Stars. Galaxies. The entire universe. Converted to a new state where life is impossible. How likely is this? We don't know. The calculations depend on the exact mass of the Higgs boson and the top quark. And the measurements have uncertainties. But the best estimates suggest we might be in a metastable vacuum. The universe might be perched on the edge of collapse, waiting for a quantum fluctuation or a high-energy collision to trigger the decay. And when it happens, there's no warning, no escape. The bubble expands at light speed. You can't outrun it. You can't see it coming. You just stop existing. The universe might have a built-in self-destruct mechanism, and we wouldn't know until it activated. This is the ultimate proof that the universe wants us dead. It might be fundamentally unstable, ready to collapse into a state where life cannot exist, at any moment, for no reason, and there's nothing we can do about it. Now, let me connect this to the biggest question in all of science, the Fermi paradox. If the universe is so vast, if there are billions of habitable planets, where is everybody? Where are the aliens? Why is the cosmos silent? I've been thinking about this for decades, and the answer is becoming clear. The universe kills them. The universe kills everyone. We're not special. We're not the first civilization to arise. We're just the ones who haven't been killed yet. And it's only a matter of time. Look at the evidence. Gamma-ray bursts, asteroid impacts, stellar evolution, radiation, vacuum decay, supernovae. The universe has 1,000 ways to sterilize planets, and it uses all of them. The galaxy is 13 billion years old. There has been plenty of time for civilizations to arise, and plenty of time for the universe to kill them. Every single one. This is the great filter, the concept proposed by Robin Hanson. Somewhere between the formation of a planet and the colonization of the galaxy, there's a filter, a barrier that prevents civilizations from spreading. And the filter is so effective that we see no evidence of any civilization that passed through it. The question is, where is the filter? Is it behind us? Did we already pass the hard part, or is it ahead of us? Are we doomed? I think the filter is everywhere. I think the universe is the filter. The universe itself is hostile to life, and the hostility increases as civilizations become more advanced. The more energy you use, the more visible you become. The more visible you become, the more likely the universe notices you and eliminates you. Gamma-ray bursts don't target pre-technological species. They target everyone. But advanced civilizations, ones that spread across multiple planets, ones that build megastructures, ones that use vast amounts of energy, they're more likely to encounter the universe's killing mechanisms because they're in more places, exposed to more threats, and eventually one of the threats succeeds. Think about it. An asteroid can wipe out life on one planet. But if you've colonized 100 planets, asteroids are no longer an existential threat. So the universe escalates. Gamma-ray bursts can sterilize multiple star systems at once. Supernovae can devastate regions of the galaxy. Vacuum decay can destroy the entire universe. The universe has weapons scaled to every level of civilization, and it will use them. The silence of the cosmos is not because civilizations are hiding. It's because they're dead. The universe killed them, all of them, and it will kill us too. We're just not dead yet. We're living on borrowed time, in a brief window between the formation of our planet and the inevitable catastrophe that ends us. Maybe an asteroid, maybe a gamma-ray burst, maybe the sun, maybe vacuum decay, maybe something we haven't even thought of yet. The universe has options. And here's the most disturbing part. We can't escape. Some people think we'll spread to other planets, build colonies on Mars, terraform other worlds, become a multiplanetary species, and that will save us, but it won't, because the universe wants us dead everywhere. Mars is bombarded by radiation. It has no magnetic field, no atmosphere. Living there requires constant technological support, and technology fails. A single critical system failure on Mars, and everyone dies. Colonies are fragile, and the universe is relentless. Spreading to other planets just means more targets for the universe to hit, more chances for something to go wrong, more opportunities for extinction. The universe doesn't care if you're on one planet or 1,000. It will find you, and it will kill you. Some people think we'll achieve interstellar travel, spread across the galaxy, ensure our survival through sheer numbers and distribution. But interstellar travel is almost impossible. I've talked about this before. The energy requirements are staggering. The radiation exposure is lethal. The timescales are prohibitive. And even if we manage it, even if we somehow build ships that can cross light years, we'd just be spreading into a galaxy that's trying to kill us. Every star system has asteroids. Every region of the galaxy is bathed in radiation. Gamma-ray bursts can happen anywhere. Supernovae can happen anywhere. We can't escape the universe. We're trapped in it. And it's a death trap. The only question is how long we survive. Decades, centuries, millennia. Eventually, the universe wins. It always wins. Let me tell you why this is actually the correct solution to the Fermi paradox. We're not alone because life is rare. We're alone because the universe kills intelligent life systematically, efficiently, without exception. Life arises, it evolves, it becomes complex. Maybe it develops technology, maybe it builds civilizations, and then the universe notices and eliminates it. An asteroid, a gamma-ray burst, a nearby supernova, stellar evolution, vacuum decay, any of 1,000 mechanisms, and the civilization ends. Maybe they see it coming, maybe they don't. It doesn't matter. The universe doesn't negotiate. It doesn't give second chances. It kills, and then it moves on, and life starts again somewhere else, and the cycle repeats. This is why the galaxy is silent, not because intelligent life is rare, but because it doesn't last. The universe makes sure of that. And here's what keeps me up at night. We're not special. We're not chosen. We're not protected. We just haven't been killed yet. And that's only because we've been lucky. Incredibly, impossibly lucky. We haven't been hit by an extinction-level asteroid in 65 million years. Long enough for mammals to evolve and diversify and for humans to arise. If that asteroid had come 10 million years earlier or 10 million years later, we wouldn't be here. We're the product of timing, of chance, of a brief window where the universe wasn't actively trying to kill us, but the window is closing. The universe is patient. It can wait. It has all the time in the universe, literally. And eventually our luck runs out. Maybe tomorrow, maybe in 1,000,000 years, but it will run out. And when it does, the universe will succeed and will join the countless other civilizations that arose and died and left no trace, because the universe erases everything. Eventually. This is the proof. The vacuum that surrounds us, the radiation that fills space, the asteroids that bombard planets, the gamma-ray bursts that sterilize star systems, the sun that will eventually boil our oceans, the possibility of vacuum decay that could end everything instantly, the silence of the cosmos where there should be 1,000 civilizations shouting into the void. All of it points to the same conclusion. The universe is not neutral. It's not indifferent. It's hostile. Actively, systematically, relentlessly hostile to life. And we're surviving not because we're strong, not because we're smart, not because we're favored. We're surviving because we've been lucky. And luck doesn't last forever. So what do we do with this knowledge? Some people might find it depressing, nihilistic. What's the point if the universe is going to kill us anyway? But I find it clarifying. It focuses the mind. If we're living on borrowed time, if every moment we have is a temporary exception to the universe's rule, then every moment matters. Every discovery matters. Every connection matters. Every thought, every idea, every experience is precious because it's fleeting, because the universe will erase it all eventually, and that makes it valuable. We're not here because the universe wants us here. We're here in spite of the universe. We're a rebellion against entropy, against heat death, against the void. We're complex structures in a universe that prefers simplicity. We're order in a cosmos that trends toward chaos. We're consciousness in an unconscious universe. And that's extraordinary, not because we'll last forever, but because we exist at all. The universe wants us dead, and the proof is everywhere. In the vacuum, in the radiation, in the asteroids, in the gamma ray bursts, in the sun's slow brightening, in the possibility of vacuum decay, in the silence of the cosmos, in every law of physics that grinds structure down to equilibrium. The universe is a machine designed to destroy complexity, and we're the most complex things we know of. Which means we're the universe's primary target. It's trying to kill us right now with 1,000 different methods, and eventually it will succeed, but not yet, not today, right now, against all odds, against every mechanism the universe has deployed. We're still here, still thinking, still asking questions, still trying to understand, still defying the void. And that defiance, temporary though it may be, is the most beautiful thing in the universe, because it's the only thing that fights back, the only thing that says no to entropy, no to heat death, no to the void. We exist, and the universe hates that, but we're here anyway, for now, and maybe that's enough. Maybe that's all we get. A brief moment of consciousness in an unconscious cosmos, a temporary rebellion against the machine, and then the universe wins, and we're gone. And the cosmos moves on, silent, empty, dead, just like it wants, just like it's always wanted. The universe wants us dead, and someday it will get what it wants. But not today. Today we're alive. And that's proof that even the universe, with all its weapons, with all its hostility, with all its power, can't kill everything instantly. It takes time. And in that time, we get to exist. We get to think. We get to understand. We get to marvel at the very cosmos that's trying to destroy us. And maybe, just maybe, that's the whole point. Not to win, but to exist anyway. To defy, to persist, until we can't anymore. The universe wants us dead, and the proof is everywhere. But we're still here, and that's the most defiant fact in all of physics.